Good morning, folks. We are back on the internet talking about our next topic. Now, this topic that we have, angles and circles, has three different sub topics that we're going to be jumping into. So, we're going to have three different parts on this. First one, we're going to be talking about our central angles and inscribed angles. Then, we're going to be talking about angles formed by intersecting chords. And then, angles formed by intersecting secants and tangents. So we have a lot of different things that we're going to be talking about. Make sure you stay tuned for all the different parts, and let's jump into our first one. So let's do a brief review over what a central angle is. A central angle is an angle made up of two radii whose vertex is at the center of the circle. So when we talk about radii, that's the plural for radius, aka the line that comes from the center out to the very circumference, the edge of the circle. Now, when we have a central angle, we have this brief little formula here that works out for us. So, the central angle measure is always going to be equal to the intercepted arc measure. Now, what do we mean by intercepted? When we say an intercepted arc, that means that what angle we're looking at, for instance, this one B, is equal to the arc that's made up of the other two sides of angle B, A and C. So this arc AC is what's being intercepted by angle B. Now, B is the same thing as this is the same thing as B. So in our example here, we have this arc here from Q to S. Q to S is intercepted by our friend angle R. So that means angle R, its measurement is equal to 80 degrees. So one is equal to the other is equal to the one. Now, a related theorem that we're going to have with this is that in a circle or in congruent circles, congruent central angles have congruent arcs. So if you have multiple central angles inside of your circle, that means that those arcs that are made up of those congruent angles will be congruent. All right. Now, our second part that we're going to be talking about, we're going to talk about a new type of angle here. We've talked about central angles, but this time, let's talk about what an inscribed angle is. This is made up of two intersecting chords, so a line that goes from one edge of the circle to the other edge of the circle, and whose vertex is on the circle. So when we talk about vertex, remember that's the corner of your angle. So this right here, JK, that's a chord that meets over here with LK. They both meet here at point K, which makes us this angle here, JKL, or you might want to call it LKJ, or just simply angle K. Now, when it comes to measuring this angle measure, we have to know that the inscribed angle is going to be equal to 1/2 the size of our intercepted arc. So angle K here is half the size of arc JL. And then if you were going in the reverse, if you needed to find the arc measure from the angle, you would just double the arc measure, aka multiply it times 2. Now, over here in our example, we have angle N over here marked as 31 degrees. They want the measurement of MO. This MO, this arc, is intercepted by this angle N. So that means that the size of MO, it's double the size of angle N. So we got 31 times 2. That gets us a nice easy 62. All right. Now, along with our two definitions, central angles and inscribed angles, we have a couple of theorems that we want to make sure we hit for those special cases. Our first theorem we have says an angle inscribed in a semicircle is a right angle. Now, this is also called Thales' theorem, but we're not going to have to commit that to memory. Remember what a semicircle is? That is half the circle. So, if a regular circle, the whole circle, is equal to 360, a semicircle is half of that, which is equal to 180. So just like with our inscribed angle measure before, if arc, that arc that's made up of half the circle, that's equal to 180. And that inscribed angle to that half of the circle, that would be half of it, so 90. So that's just a nice little way that we can just remember that real quick. Now our next theorem says that the opposite angles in a cyclic quadrilateral are supplementary. Now this might be a new little bit of mathanese here. When we talk about cyclic, that is in a circle. So a cyclic quadrilateral is a four-sided shape where all of the corners are touching the circle. I know mine didn't touch over here, but you get what I'm saying. It's a four-sided shape inside of that circle. And then, a blast from the past, our good old friend supplementary. If you don't remember what supplementary means is, we had two things that add up equaled to 180. All right, our final theorem here says that in a circle, inscribed angles that intercept the same arc are congruent. So if I had another angle over here, let's say I just come over here, I'm gonna make another little chord and another chord right over here. So imagine this is J, K, L, M. This here is point M. Now these two angles intercept this same arc here, JL. That means that just like how this was half a JL, this angle over here by M is also half a JL. That will pop up periodically. So if you do see these things, just remember these different theorems. They're good little shortcuts for special cases. All right, let's get into a couple of examples with our we do it. Our we do it has these two top circles here. So let's note some information we have. This top circle has several angles here located from the center out to all of these. So that means that whatever each of these are for these central angles, these arcs are outside. So if this is 130, this arc here from L to M is also 130. If this is 79, this arc here from J to N is also 79. All right, now we got a couple of other angles here that we need to figure out. So let's figure out something right now. Let's first look for this one here. This is coming from K to the center over to L. If I wanted to find this, I need to remember what these two are inside of. They're not only inside of a circle, but they're inside of a certain kind of angle. That angle being a straight angle. So this 130 and this blank angle make up 180. So let's figure out what this is by doing some nice, neat subtraction. So we got 180 minus with 130. So 1 and the 1 cancel out. There's nothing happening here with the zeros, but we got something happening here with the 8 and the 3 though. 8 minus 3 is 5. And when we drop down that 0, that tells me that this angle up here is 50. Now, along with us being able to figure out this, let's figure out another angle real quick. So let's go through. I'm going to do a light bit of erasing. If I wanted to find this middle angle right here, I know that these three angles this time are inside of a straight angle. So let's go through and do some light bit of subtracting. So over here, let's go through and do some subtracting. We got 180. If I take away that 50-degree angle, that gets me to 130. And if I take away that 79, that 79 ends up giving me a, let's go through and borrow that, turn that to a 13, turn that to a 10, so we got to turn that to a 12. This should be 51 for this angle. So, along with what we had here from before, we now know a couple of these angles. We also know what this other blank one is right here. Just like how we were able to go through and subtract over here to find this 50, if we did this in the other way, this would also be a 50. All right, now we got all the angles here nice and handled out with some nice neat subtraction. Let's do some more information for us. So remember what we said. We don't really need all this information other than the fact that each of these central angles and each of these arcs that are intercepted by them are congruent. So that means that whatever this is, 51, this is also 51. This arc here is also 50. This big one here is also 130, also 50, and this is also 79. All right, now that we did a whole lot of detective work, people, let's figure out the measure of our arc here. Remember, when they give you three letters like this, three letters in an arc means that it's a major arc, meaning it's going to be bigger than 180. So let's map out where our arc is. We're coming from J past K over to M. So that means I need to add these three together. 51, 50, and 130. When I add all three of these together, I get a final answer of 231. So, a little bit of light detective work, but we were able to figure out what we needed to get. All right, next one that we got going on here. We got some detective work we got to do beforehand. We first need to know what we're looking for. We're looking for an arc measure. Now, I look at what's inside of this. There's no central angles, but there are quite a few inscribed ones. So that means I need to be able to go through and find each of these inscribed angles. I have two of them right now, 71 and 53. Let's find this one up here. This is a triangle here, so that means that all three of these angles add up to our good old friend 180. So when we do 180, we're going to subtract 71 first. That's going to give me a 10. This is going to be 109. Now from 109, we're going to subtract 53. So 109 minus 53, this is going to give me 56. So this angle here, R, is 56. Now remember what we talked about before with inscribed angles. When we want to find this arc measure here and this angle here, 56, they're related. This angle is half the size of QS. So if we wanted to find QS, we're just going to multiply instead, because that's the opposite of taking half of something. So that's our answer there. All right, next thing we got some tough ones over here on the I do it. I want you to pause the video, take a look, come back, and then we'll go over it. All right, people, I hope you went through and took a break from the video so you could take a look at these two questions, but let's go through and answer this section. First off, we're looking for arc AC. That's this big old one from A to C. Now, it's not big like our last one up here for the we do it because they didn't give us three letters. So that means that this thing, whatever it is, this is going to be less than 180. So we don't have to worry about it being too crazy. But we're going to have to figure out what these x's are so that we can figure out this. All right, first over here, I know that this is outside of the circle, meaning that this is an arc measure. Same thing with this. This is an arc measure. But each of these angles is located with its vertex at the center. That means whatever the arc measure is equal to whatever the angle measure is. Same thing over here. That arc and that angle, they're both the same. So if these two are the same, let's go through and understand some more things from the markings we see. I see that this and this, these are the same type of arc that we are seeing inside of these angles. Whenever we see this symbol, that means that these guys are the same. So we have two of these, 5x plus 10. I'm going to go through and try to write that in. You know what my handwriting's like, folks. All right, pretty clean, pretty clean. Now, if these two 5x plus 10s are here, how is that going to help us out with this angle here? Well, if we look at the structure of what's happening, the sides from this big angle down here, 12x minus 2, make straight lines with these two smaller angles over here, which means this and this are a set of vertical angles that are equal to each other. Let's go through and figure out what we need to do. If they're both vertical angles, that means they're congruent. So these are our equation for us to solve. So we got 2 times 5x plus 10. And then on the other side, we got 2x, not 2x, 12x minus 2. All right, we see parentheses here. We don't like that stuff. We want to uncomplicate this. So let's distribute. That's giving us 10x plus 20 equal to 12x minus 2. I want to get all my constants to one side, all my variables to the other. So if I take this 2 and bring it over here, that's us adding 2. If I take this 10 and bring it over here, that's us subtracting 10. So we would end up with 22 is equal to 2x. When I divide both sides by that 2 next to the x, what's next is I get x equals 11. Now that we know this, we got to go through and figure out our angle that we have here. If I take this x and plug it into these angles, I end up with 5 times 11 plus 10 gets me 65. So this thing here, this is 65. If this is 65, so is this. And if these two are both 65, that means that together they make up 130. Yeah, the angle that we want, not the angle, the arc that we want is from A to C. So that means I unfortunately got to figure out what this is. But we've actually done the subtraction earlier today. See, if I look at this, this is 180 minus 130, which means this angle here is 50. So if I add this and this together, that 50 and that 65, that gets me a final measure of, when I add those two together, let's erase that. That's honestly better than my handwriting. 50 and 65 add together to give me this arc, 115. Okay. All right. A little more straightforward on the case for this second part of the we do it. We have us an inscribed angle to this arc, 184. Remember, this thing here, this is half of this arc here. So if we want to figure out what x is, we're going to just take that 4x minus 12. Instead of us dividing it, because we don't really need fractions early in the morning, we're going to multiply that to make these guys the same. So 2 gets distributed into that parenthesis. That gets me this 4x, not turning into a 8x, and this negative 12 turning into a negative 24. We continue solving. We subtracted that 24 earlier, so that means we're going to add it now. That's where I get this 208 from. When I divide both sides by 208, I end up getting, not by 208, by 8. That's a lot of 8s, people. When I divide both sides by 8, I end up getting an x that is 26. All right. Now, folks, we got 3 last ones here. They're a little bit of a doozy, but I'm going to help you out nice and easy. These are all going into some of our theorems that we had going on earlier, and as well as a set of central angles over here. So, our first one that we got going on here, we see a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles are supplementary. So, our 7x minus 5 and our 6x plus 3, those are both supplementary. Likewise, the other two angles, 23y and the 37y, are also supplementary. So let's solve these both. I continue to combine my like terms from this equation. I have to move on and add the 2 and then divide by the 13. That gets me this 14. For the other one, a little bit of a shorter way. We have 37 plus 23. That's where I get my 60y. When I divide both of these guys by 60, that ends up giving me a y equals 3. Okay, nice and easy. Now, over here, they want you to find the measure of angle AEB, which is this angle right here. But let's get some context. This is a central angle. Central angles are equal to their intercepted arcs. But there's nothing up here. But there is something down here. These two here, they're a set of vertical angles. So these two are both congruent. And since this is also a central angle, this 8x is actually the same size as this, which means that this here is also 8x. Oh, no, that's crazy. The pen had a mind of its own, folks. 8x, bam. So, what do we do now, though? I see something's familiar. We got us a set of angles that are going to make a straight angle. So when I do this, I got 14x plus 15 plus 8x is going to equal to 180. You got to combine your like terms and move your constant. So adding that 8 with that 14 is going to give you a 22. And moving that 15 to the other side means we have to subtract, giving us 22x is equal to 165. Next, I got to divide by 22. This is going to give you a decimal, but decimals are answers, folks. Remember what I tell you. So that gets you 7.5. Now that you have 7.5, remember, we need to figure out what AEB is. So that means we're going to be taking that 8 from our expression times that 7.5, which gives me a final answer of 60. There we go. All right, final round. Let's get into it. On this one that we got here, we have 5x on the inside that we need to solve for, and we got these two on the outside that we got to go through and find and solve for. Now this line here, this is going to help us out. This line is actually going through the center and cutting this circle in half. So if this circle is being cut in half, that means that this is a semicircle. And this is an inscribed angle in a semicircle. Inscribed angles in semicircles, they're going to be 90 degrees. So that handles our first thing here. 5x here is actually equal to 90. So when we divide both sides by that 5, my answer is 18. Now, just like how that was one way we can go through and use our theorem to our best of our ability, we also have another theorem that we have going on here, or at least some information that we could pick up from here. This angle is not only 180, but it's also located at the center. Central angles are equal to their intercepted arc, which means that this big old arc here is 180 in total. So these two need to be set up equal to 180. All right, we go through and we combine our like terms. We got 7y plus 13y. We got negative 10 plus negative 10. That gets me 20y minus 20 equals 180. When I divide both sides, not divide both sides, should I have to take that 20, add it to both sides, then I'm going to have to divide. So adding the 20 to the other side gets me a 200. And then I divide that 200 by 20, which gets me 10 for my y. Folks, thank you for watching. I understand that this was a bit of a doozy, but I hope that this was able to make it a little bit easy for you. Tune in for our next part, folks. We are going to be talking about angles formed by chords.